So BGP. What is the first question? What is a plural form of BGP? Yeah, full form. Yeah. Border Gateway Protocol. Yeah. It is an application layer protocol. Which layer protocol is it? No, it is an application layer protocol. Layer 7. Layer 7 protocol. Yes, it is a layer 7 protocol which uses TCP at layer 4. That is transportation. No, transport layer. Okay. It uses port number 173. Yeah. Okay. Viral, sorry, I can't hear you. Better be close to your mic. Yeah, this is better. No. BGP doesn't support BGP. Yes, only TCP. Okay. It is a path vector protocol. Path vector protocol. Okay. Yeah, it is a path vector protocol. Right? Yeah. It is primarily used to exchange routing information, sorry, between the different AS, different AS, autonomous systems. Okay. Yeah, I'm recording it. So it is just about these 5 lines, 1, 2, 3, 4, 5 lines are just the basic points of BGP. Whoever is speaking about BGP, whoever tells that they know BGP, they should know these 5 points at any cost. You getting me? So BGP is a application layer protocol which uses TCP at layer 4, which uses port number 173, which is a path vector protocol, and it is primarily used to exchange routing information between the different AS. Okay. So as part of today, even before we starting about the BGP, we have some topics to discuss, right? First thing is, what is an AS? That is autonomous system. Why do we use it? What is its role in BGP, right? So what all you know about an autonomous system number in AS? Uh-huh. Yeah. Yes. Mm, that's correct. Now, what is the definition of an autonomous system? System. Yeah. Okay. Yes, that's correct. And let me define autonomous system is an identity given to any organization in order to define their in order to define their networks and configure their routers, right? This is a basic definition given to every CCNA candidate. Every CCNA candidate will say the same thing, that is what is an AS number. AS number represents an authority. AS number represents an authority, and it will tell that these all routers belong to this authority, right? But actually, if you are speaking technically, an autonomous system, an autonomous system number means that whatever the whatever the routers are there under it, all will share the routing information using only one routing protocol. That which this routing protocol is again an interior gateway protocol. Okay, if you analyze once till now, up to according to your knowledge, if till now whatever you learned about autonomous system, whatever the routing protocols you have seen, just correlated and just once analyze that, you will tell every routing protocol, that is whatever it is, advanced distance vector or link state routing protocol, whatever it is, you will define a separate AS number for it. No two separate routing protocols will have same AS number. Have you ever seen two different routing protocols having the same AS number? Yeah, that is a thing. That is a thing. So the autonomous, yes. So technically, autonomous system number means that whatever the routers are there under it, under this autonomous system, will always share the routing information using only one routing protocol, and again that routing protocol is an IGP, right? IGP, Interior Gateway Protocol. Okay. Now That's great. If we want to share routing information in an AS, in an AS, for suppose think these are my two AS, okay. For suppose think this is Tata and this is Airtel, right? If Tata network customers want to speak with their friends who are in Airtel, can they be able to speak until and unless there are no routes between these two AS? Can they be able to speak each other? Yes, yes. See, but these yes, we have to exchange routes. See, this is my core network of my Tata, and I am somewhere connected here, right? And I want to speak to my friend who is in Airtel network here. I am sending a message hi to him, right? Hi, it will be encapsulated in the IP, right? And every router will check it where the network is. It will come here, but here it doesn't know that that network, whatever the destination network I send this packet, it doesn't know that that network is in this AS. Will it forward? It will not forward, it will drop the packet. So in order to share the routing information in an AS, IGPs will always help us. IGPs, interior gateway protocols, will always help us, right? Viral, I just want your reply from you until and unless I cannot go forward, because I have to know whether you're able to get it or not. If you are unable to speak, you just send me the message in the chat. I can understand it. Okay. Yeah. So the IGP, whatever the protocol is present, which is underlying under one AS, it will help all the routers to exchange the routing information. But what if the information must be exchanged between two different AS? Who will help us? This is the first and important primary question. Who will help us regarding this exchange of information? Yeah, between two autonomous system members. Yeah, now this complete AS has to exchange the routing information. Whatever networks it has to give it to this AS, and whatever the information does this Airtel has, it has to give it to Tata. Until and unless if, the customers of Tata will not be able to communicate with the customers of Airtel, right? If they want to communicate, they need some connectivity between them. Then this exchange will be how this exchange will be done, right? Yeah, yeah. The one of the points you told was correct. That is static. Static IP, giving a static route. Okay. Okay. You told that we can give a static route. But have you ever read that static routing is feasible only when there are less number of networks? But actually on the internet, if I have drawn a small diagram and I told that this is a AS number, this is a complete one AS and its name is startup. But actually, you know what? Actually, the A1 AS contains how many number of networks does it contain? It consists of around some hundreds of thousands of networks. For how many networks will you do static routing? Right? Okay. And the other point, whatever you told, that is a Cisco Express forwarding, right? This works only when you want to switch the packets from one network to another network. For suppose this is my 10 and this is my 20. I want to switch the data from 10 to 20. Then my Cisco Express forwarding on the Cisco routers comes into play and it will take the decision. But until and unless it doesn't have the route to 20, it will not forward the packets. Okay, so this is some other concept. Okay, right? So here, if I will give a static route, I can give for maximum, at max I can give for 100 networks, but there are some hundreds of thousands of routes. How can I give it? Right? So we can tell one solution, that is redistribution. Redistribution. Yeah. Yes. So what will we do is, for suppose thing, this is my data, my core network data, and this will be our another network, Airtel or AT&T, right? So now they are interconnected. For somehow they are connected, and our Tata AS is using OSPF, and our Airtel is using yeah, EIGRP, Enhanced Integrated Gateway Routing Protocol. For somehow we have done redistribution. We have done redistribution, and even the OSPF also does redistribution, right? You will be having many problems with multiple redistribution points. Okay, through a single redistribution point, we cannot redistribute these many networks. First thing. Second thing, if we want to redistribute these many things, we need multiple redistribution points. And if you are redistributing in multiple points at multiple ranges, you will be having problems like loops, which occur based on ADC, administrative distance values. And one more thing, it is not efficient. Only one-way communication will be done. Other two-side communication will not be possible, right? So in order to avoid these problems, we can use BGP, right? One of the problems is solved. Loops will be avoided, and it will be efficient communication. First thing. Second thing is, if you are using OSPF, actually OSPF and EIGRP, whatever the IGP protocols are existing in the world today, in the world of networking, they are never developed. They are never developed for handling more than 1,000 routes. More than 1,000 routes or 1,000 networks. First of all, what happens? The OSPF will crash down, it will shut down if it is containing more than 1,000 routes with it. Why? Because its code is not that efficient to handle these many networks. That is why they built BGP. Okay, so they cannot handle these many number of routes. Actually, if we are speaking today in the network, there are around 500,000 of networks, and our EIGRP and OSPF, they are not even able to handle thousands of networks. Then what about the networks which are 500 times of that AIGRP or OSPF can handle. You are getting my concern? You got it, right? They cannot even handle thousands of routes. How could they handle 500,000 of networks? Right? So in order to avoid such simple problems, they came up with border gateway protocol. Right? Border gateway protocol. So actually border gateway protocol how it is handling these number of routes, how it is handling this many number of routes, and how it is efficient, using to OSPF, EIGRP and whatever the IGP protocols are existing, how it is efficient in using BGP to the OSPF or EIGRP. Okay, I'll tell you 4 points. Reliability, scalability, flexibility, and flexibility. Reliability, scalability, flexibility. So how it is reliable, how it is scalable, and how it is flexible. Okay, in whatever the way you speak, or in whatever the way you compare these IGPs with BGP, EGP protocol BGP, it is reliable to OSPF and EIGRP, it is scalable to EIGRP and OSPF IGP protocols, it is flexible, more flexible than OSPF and EIGRP, that is interior gateway protocols. Okay, how it is reliable? If you are speaking EIGRP, it uses reliable transfer protocol. Reliable transfer protocol. Yeah, it is used by EIGRP, which is its proprietary protocol, in order to maintain reliability. Right? And if you are speaking OSPF, SPF provides it reliability. Right? But if we are speaking about BGP, Border Gateway Protocol, the most reliable protocol, that is TCP, is used by the BGP. Being it as a layer 7 protocol, at layer 4 it uses TCP. Okay, we know how much reliable the TCP is. If we start speaking about TCP, the 20 days of session is not sufficient for speaking about TCP. Okay, so that TCP is that much reliable. Okay, so BGP is using TCP for its reliability. BGP is using TCP for its reliability, and even before the BGP exchanging the routing information, or even before establishing a neighbor relationship between other routers, BGP will use TCP three-way handshake. Then only it will be going for the neighborship. Once it is done, then it will be going for exchanging the routes. This is BGP. If we are comparing TCP with RTP and SPF regarding reliability, TCP is some hundreds of times more reliable than the RTP and shortest path first. So in this way, BGP is reliable than OSPF and EIGRP, or else we can speak interior gateway protocols. Yeah, if now we have just started with BGP. In BGP, we'll be having around eBGP and iBGP. That is two types of classification. That again depends on type of neighborship. We'll discuss about it. Okay. For time being, remember that BGP is more reliable than EIGRP and OSPF. Okay. One is done. Scalability. Scalability is if there is a misbehaving interface. If there is an misbehaving interface, right? For suppose think it is malfunctioned and it is coming up and going down for around 6 times in a minute. 6 times in a minute, right? How to control this? It is a physical property, we cannot do anything, but whatever the network connected to this interface, an update will be generated that it has gone down, and whenever it comes, an update will be generated that it has come up, right? You're getting my concern?
Yes.
If it is such misbehaving, every time whenever an update is generated that it has gone down, and whenever a update is generated that the route has gone down and route has come up, the router has to recalculate the algorithm on that update, right? For suppose think this is my interface with 10.0.0.1. It has given the route to dynamic routing protocol, has given that route to R1. R2 has given it to R1, telling that if you want to go to 10 network, I am very much reachable to it, right? Now immediately this interface has gone down, it will generate an SPF, it will generate an update. It will tell router 1 that this interface has gone down, this network is not existing anymore. Then this router, it will not just remove it, it will just calculate an algorithm on it, by which it will come to know that it is not reachable to this through this way. Now it has to calculate some algorithm and it has to find some other way to reach the 10 network. So if this happens once, it's okay, but for in a minute, per minute, it is happening 6 times. The router's processing will be increased. The problem is persisting. Every time an update is generated, the router has to calculate an algorithm. It has to generate an update. First, it has to update its routing table. Then it has to generate an update. Then it has to send it through all the interfaces. And even before doing all this, it has to calculate an algorithm on it, whether it has any other path to reach the 10 network. Okay, and now this update is given to R1. Now again R1 has to calculate an algorithm. It has to find some other path, whether it has some other way to reach it or not. Okay, and then it has to update its routing table that it is not reachable to 10.1 through this interface, and it has to update some other path through which it can be reachable. We are speaking it very simply, but it is a very big work to router, right? Decreasing this work of the router, or decreasing that work of routing protocol, is called scalability, right? If you are speaking about OSPF, in OSPF we are having some mechanisms to bring more scalable. That is, we have SPF throttling, LSA throttling, right? Yeah, these are some throttling methods where we will tell OSPF that please don't generate if the problem is persistent. Generate it after every one interval. If the problem is persistent, in 1 minute it is happening for around 6 times, we'll tell OSPF that don't generate it 6 times. Instead, you just generate 1 time. By this, what happened? The burden of this router will go down. And second thing, the same thing happens with other routers also. The burden will be going down, and they don't need to calculate any algorithm on it, right? This is SPF and LSA throttling. We will tell OSPF not to generate any LSS. This becomes LSA throttling, and we will tell the other routers not to calculate. Though if you receive the update, LSA update, don't calculate SPF on it, algorithm on it for this interval, for this time of interval. Whatever the number of updates you have received, stop calculating algorithm on it. By this, what happened? We have decreased the burden of the router, and we are making the route stable. But in BGP, we have a very good solution for scalability. We'll discuss as a part of our course, but BGP is more scalable than OSPF and EIGRP, right? It will check the persistence of the problem, and if it is persistent, then it will make that network aside. It will not care about that network for some amount of time. Whatever has happened to it, it will not care for that amount of time. After a periodic time, it will go and check it. If the problem is still persistent, it will keep it aside, right? That we can do using some path attributes. We'll discuss it later, okay? But compared to OSPF and IGP protocols, BGP is more scalable, okay? Okay, and that process in BGP we call it as route dampening. Okay, we will discuss it. Okay, for timing, just remember this. Okay, so in this way, this is scalable, right? Flexibility, scalable. Flexibility. Why are we using this term flexibility? Usually, what do you understand by word flexibility? In a layman language, it is like molding according to the situation, right? The same goes with the BGP. Actually, in EIGRP or in OSPF, the IGP protocols, if you want to control the path or control the inflow or outflow of the traffic, inbound control and outbound controlling of the traffic, both simultaneously, it is not possible with interior gateway protocols. You can only control the outflow of outbound traffic. Only outbound traffic. Whatever the traffic is incoming, you cannot take any control of it. If you are receiving it, you have to receive it. That's it. You cannot tell that I am not accepting it. You go to another router. You cannot tell it. Right? And one more thing is, if you even this outbound traffic control, if you want to do, you can only do it with two values in EIGRP, that is bandwidth and delay, right? These are the only two parameters in EIGRP through which we can calculate the metric value, based on which you can, if you change the metric value, the path will be manipulated. Path manipulation is possible in EIGRP only through two values, that is bandwidth and delay. In EIGRP, if you are speaking about OSPF, we will be having only right? If I want to path manipulate, I will be having only type of routes, that is E1 and E2. And one more thing is how we calculate the metric bandwidth. These are the only parameters, three parameters based on which I can path manipulate use in the OSPF, right? Always even routes will be more preferred than E2. Based on these criteria, I will make path manipulation. And if I am receiving the interface, if I am receiving the two routes, I will increase bandwidth of one interface of one route, and by which it will be going to outbound traffic will be going from another route, and one traffic for one network will be going to this interface by changing the bandwidth of the interface, or else by using offset list, prefix list, whatever the filtering method you have. By using these filtering methods, we can change the path, right? In EIGRP, we will be having only two parameters, and in OSPF, we will be having only three parameters through which we can route our network in the way we want it. But if we are speaking about BGP, border gateway protocol, we have 12 path attributes. 12 path attributes. Using these 12 path attributes, Using these 12 path attributes, we can manipulate the path of our network, or the receiving, whatever the network we are receiving, we can manipulate that path according to our wish using these 12 path attributes, which will be more flexible, right? Here, if you have used these three, you are done. We cannot use more than these three. And if you want to play, you can only play with these three parameters, right? But here, you are having 12 parameters. Simply we call it as path attributes. Using these 12 parameters, we can change our path according to our wish, right? It is very simple, like you are driving a Maruti Swift and you are driving a Porsche car on a highway. You will be having less options with Maruti Swift. But if you want to go as much speed as you possible for you, if you want to go, we'll be using Porsche, where you can play. It has many features. How to control the speed, and at what time, whatever you want to do, you can do it with your car. But if you are once going at 100 kilometers speed on your Maruti Swift, if you want to control your speed, you cannot. It takes some time. But whereas Porsche can do it within seconds. Like this, if you compare this example with this, you can able to understand. EIGRP or OSPF is like a Maruti Swift and BGP is like a Porsche car on the highway. You will be having more flexibility. Within a second you can go to high top speed, and within a second you can come back to stop point. But whereas for a Maruti Swift, you cannot do it. The same thing with BGP and IGP protocols. Okay. Upon all these features, we all prefer BGP more than IGP because of this reason, but that is it can handle more the number of networks. Yeah, than any other routing protocol can do. Yes. Right? It can handle more the number of routes. That is around 500,000 of networks. It can handle it. Right? BGP is an exterior gateway protocol. Why it is exterior gateway protocol? Why? Because we use BGP for exchanging information between different AS. Right? Why we use only BGP? Why? Because these are all the features that is provided by the BGP compared to the IGP. Right? So now can I say in a strong point that BGP is an exterior gateway protocol? Can I say it? Yes, so that is why I wrote this point at the last. Okay, it became EGP, Exterior Gateway Protocol, because it is behaving according to it. It has to behave in the way it is doing its work in that form way. That is why we call it as Exterior Gateway Protocol, because it is flexible, it is scalable, it is reliable, and it can handle the more the number of routes than any other routing protocol can do. Right? So out of our part, what is an AS number has finished, and we have gone to some other thing. So why do we use it? AS number to no. I'm speaking about autonomous system. I'm speaking about autonomous system. Why we use is to identify to which authority does this route network belong, or to identify to which routing protocol has given me this network. In order to know this, we use autonomous system technically. And if you want to speak in layman language, it is used to identify an authority, right? And what is its role in BGP? BGP has come up because of AS. BGP has come up because of AS. For suppose think there is no concept of AS number. If there is no concept of AS number where we doesn't define any authority, and if the route has to be exchanged between these two AS, there has to be no need of exchanging routes. Why? Because there is no AS number concept at all.